First, I'm going to have you read the story problem entitled Music Choir.
The choir director wants to divide the choir into smaller groups. The choir has 4 sopranos, 60 altos.
24 sopranos.
60 altos, 36 tenors. Each group will have the same number of each type of voice. What is the greatest number of groups that can perform? Harmonies, sopranos, altos, and tenors.
Okay. So the story problem is going to allow us to utilize the greatest common factor of these numbers. And I'm going to show you how that's going to work here in a second. I don't normally like to use the book example, but this is a good example. 36 times. Okay. I've got a big choir, and I want to separate it into groups. But I need to keep the ratios the same. In other words, he wants to have, if it's 24, 60, and 36 the way it is right now, he wants to divide it up so that he has a lot more altos, obviously, than sopranos. And the only way he can keep the ratios the same is by finding the greatest common factor of all 3 numbers. Now there's several different ways to do this. You can first factor each one, and I'm going to do them in order. 1 and 24, do it with me. 2 and 12, I might have not given myself enough room. 3 and 8, 4 and 6, and there's nothing with 5. So that's 24. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, no, 6, 6 times 6. So far they both share a lot, but the largest of the 2 is 12. If the largest of these 2 is 12, if 60 shares a 12, then even whatever's above it won't matter, because you need to also share with these 2. 1 and 60, 2 and 30, 3 and 20, 4 and, 4 and 15, thank you. 5 and 12. I'm going to quit right there. Even though 6 and 10 fits in there, these 2 already share this and nothing larger. So kind of by default then, as long as this also shares the 12, 12 is the one you're going to want to choose. And it does. Another way of doing it, this is the first way, they called it method 1. Another way of doing it is to prime factor the numbers. This is 3 of them, right? And you remember how to prime factor? We did that. Prime factor the numbers and take the product, which is the multiplication answer, of the common primes. All of the primes that they share. And you can actually look at your book. I'm not going to write that out for you. But what you would find is that 24 is 2 times 2 times 2 times 3. 60 is 2 times 2 times 3 times 5. And 36 is 2, 2, 3, 3. The 3 of those share 2, 2, and 3. When multiplied together, that gives you the 12. And that shared prime factorization gives you the greatest common factor of the 3 numbers. In any case, Stuart's sitting there going, well, what does that have to do with altos, sopranos, and tenors? Well, if I take each of these numbers, the 24, the 60, and the 36, and I break them up into 12 small choirs, then I will have 2 sopranos in each, 5 altos in each, and 3, tenors in each. Because I divided the big choirs numbers into 12 small choirs. This is the largest number that I could do to divide each of these numbers. So now I have 3 small choirs. I'm sorry, 12 small choirs with 2 sopranos, 5 altos, 3 tenors in each one. Let's keep going. We're going to just do a couple more things and then we're going to practice some stuff. They introduce on page 178 the term relatively prime. You guys see relatives over the break? Other than mom and dad, maybe? Aunts, uncles. Relatives are things that are related to one another. Okay? However, numbers are said to be relatively, as in related in a way that is prime if their greatest common factor is a 1. Here's an example of what that might look like. Take 18 and 24 and find me their greatest common factor. Well, we can prime factor them both and take the product, or we can list out the factors. We're going to prime factor them just for that purpose, just to practice it. Are these both divisible by 2? Yep. 9 and 12. Is this still divisible by 2? What's the next prime? Is 9 divisible by 3? Quotient is 3. Is 3 still divisible by 3? Quotient is 1. I now have the prime factorization of 18. 2 times 3 times 3. How about this? Let's keep going. Is 12 still divisible by 2? Yes. Is 6 still divisible by 2? Is 3 still divisible by 2? But what is it divisible by? So the prime factorization of 18 is 2 times 3 times 3. 24's prime factorization is 2 times 2 times 2 times 3. I'm kind of smashing it in there. 2 times 2 times 2 times 3. Notice what's shared. Both of them have a single 2, and both of them have a single 3. But Mrs. Myers, this one has two more 2's. Yeah, but 18 don't. And Mrs. Myers, he has another 3. Yeah, but he don't. Therefore, only what is shared gets multiplied together. 1, 2, and 1, 3. Therefore, the greatest common factor of those two numbers is 6. Okay, cool. It's relatively prime if their greatest common factor is 1. Is this relatively prime? No, because their greatest common factor is not 1. Remember, 1 can be listed in a list of factors, but we're not listing it when there's other stuff, because really everything is a multiple of 1. Let's greatest common factor something else. Let's do 39 and let's do 56. Is 39 divisible by 2? Is it divisible by 3? What's the quotient? 13. 13 is a prime number, isn't it? Which means it's only divisible by itself and 1. So what's it divisible by? Okay, 3 and 13. Let's do 56. Is it divisible by 2? Okay, 28, right? Is 28 still divisible by 2? Continuing 2? 2? 3? 5? What's it? So 39 is 3. 39 is 3 times 13 times 1, right? And I'm only putting it in there so that I can illustrate this. 56 is 2 times 2 times 2 times 7 times 1. Are these relatively prime? Yes, because the 1 is the only thing they share. So 39 and 56 are said to be relatively prime because the definition is all they share is a 1. Two numbers are relatively prime when the only factors they share is a 1, and that's the case here. Where it gets a little sticky, my friends, is example 3, and I'm going to go ahead and flip this here in just a second. Example 3, greatest common factor of monomials. You guys have already done this. Don't be scared of it. If you feel like you need a little bit of a pick-me-up on how to factor a monomial, you can go back to page 174. Example 3 will remind you how to factor a monomial. But in a nutshell, it's the exact same thing as factoring a number. And for variables, you just break out the exponents, making it look something like this. Let's do greatest common factor of 22m cubed p and 38mp squared. Am I the only one that wants to write mp3? Is that term obsolete now, by the way, mp3? All right. First thing you're going to do is prime factor your number. We'll do 2, 11, nothing else, right? 3, 5, down to 11, and 1. So 22 is 2 times 11. But we've got m cubed p. And what you guys learned last week, what you do with exponents is you simply break out the variable. M. P only appears once, right? Okay? 38. Not sure if I left myself enough room. Divide the number. 2 and 19? Is that right? 19's prime, isn't it? 19 and 1. I did give myself enough room. So, 38's prime factorization is 2 times 19, but I need the letters as well, which is mp squared. Break them out. M appears once, so it only appears once in your list. P appears twice, so it appears twice in the list. Highlight what's shared. What should I highlight? 2? How about letter-wise? A single pair of M's and a single pair of P's. The product of 2 times M times P is 2 times M times P. Therefore, that is the greatest common factor of those two monomials. That is the greatest common factor of those two monomials. Okay, before I let you get started,